हेलो। हाँ में क्या हो रहा है? All of you, please turn on your cameras.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening. Yes, with okay. Last session, I gave you some questions also, right? Well, all of you, please turn on your cameras. Only few students always turn on their cameras. Kindly turn on your cameras and be interactive in the class, right? Some genuine issue, some network issue is there, right? You're traveling or something. That's different, right? Okay. Let me just share the screen. So have you been able to do these questions?
Sir, I did the ninth level zone.
Okay. अच्छा इसका क्या आंसर है? व्हाट इज द आंसर टू दिस वन? यस guys, what is the answer to the first one?
Sir, 20.
What? What Devadev kya are answer? What is the answer you're getting?
Sir, I got D20 newtons.
20. 20 newtons. Okay. What about other people? Same answer you're getting? How would we be doing this question, right? This is a JEE mains question. So we have a block of root 3 kg. Same answer. Okay, Zoe is also getting the same answer. So we have this block of root 3 kg as attached with the spring, right? So whose other end is attached to the wall like this. And this is an unknown force which is being applied so that the spring makes an angle of 30 degree here, right? Now you see this thing. How can we solve this question, right? So you see this thing, this knot or this point of the string. This is a string, right? This one string. So this point of the string, as this block is at rest now, right? So this point of the string is also at rest, right? And at this point, what is the force due to the string? The string must be pulling it like this, right? With force T, tension force. And also tension force would also be here on this point like this. It is also tension force. Is it correct? And one force you can see in the horizontal F.
Yes, sir.
You do it the same way. No, I think the tension would be different, right?
Sir, it's one string. The tension will be the same.
In this string, we have the same tension. This string, we have, you have taken the tension to be same.
Sir, it's one string, right?
One string, but
So
here
tension
you
has to
see,
remain the same.
but let's say if you are saying that, let's think of like that, right? So if tension should be here now, right? And here tension would be here, right? Correct. There is no other force on it, and this point is not moving. If this is 30 degree, this is 90 degree. What is this angle? 60 degree. If this is 60 degree, what is this component of this tension? What is this component? T,
T sin 60.
right? So now you see one thing. There is no other force here, right? On this point, on this much point of the string. So that means T sine 60 degree is equal to T. Is it possible? It is not possible, no. Are you getting this, Devadev?
Okay, yes, sir. Got it.
Right? This is not possible because T sine 60 cannot be equal to T, because then T will get cancelled out and sine 60 degree comes out to be
Is
1, which is not
one.
true,
Yes, sir.
right? So tension has to be different. And why this has happened? Because there is a point where this force is being applied, right? So you can say that a kind of knot has been formed here. Getting this, right? So here we'll say, uh, right? So here we'll say the tension will be somewhat different. Let's say T dash. Let's take it. So now here the tension is T. here T dash, right? Okay. If it is here T dash, what is the tension on the block? What is the tension on the block? T dash only. Block is attached with this part of the spring, and one force is here root 3 kg. It is root 3 into g. That is 10 root 3 Newton, right? Can I say that T dash is equal to 10 root 3 Newton? Tell me.
Yes, sir.
Because this T dash has to balance this weight, no, for the block to be at rest, right? And now from here, we can say this thing that this is 60 degree now. So this is 60, so this component is T cos 60 degree. This component is T sine 60 degree. So we can say here that T, I'm writing down here, that T sine 60 degree is equal to T dash. Correct? So you tell me. So sine 60 is what? Root 3 by 2 is equal to T dash. T dash is 10 root 3. So root 3 will get cancelled out. What is T?
20.
20 Newton. So answer is 20 Newton. But this is the way, right? Can you tell me the value of F here? Can we find the value of F?
10.
How?
Sir, it's equal to T cos 60, right?
Right. So F would be equal to T cos 60 degree. So F is equal to T is equal to what? T is 20. Cos 60 is 1 by 2. Right. So it is 10 Newton. I hope you're getting this right. Because there is a force here, right? So there's a force on this point. So this point now makes this part of the string and this part of the string different, right? Because we have some external agent acting here, which is applying this force F. So you can say there's a kind of knot being formed here. Knot. You understand knot? Right? Tie. So you can say that a knot has been formed here, a kind of. Okay. What about these questions? These are JEE advanced questions. Anyone able to do this? Yes, anybody? Okay. So you just go through these questions, right? Uh, Again, right? These JEE advanced ones, right? And try to do them. Take your time, and I'll discuss it, right? If someone see that, then only it's the point to discuss that when you have attempted it, right? Then only you'll be able to learn something from it. Devadev, you did these questions.
Sir, I attempted them, sir. I want to try them again before I ask for the
So
solution.
you all of you to just try, all right? All of you just try them again, and then we'll discuss them. Okay. All right. All right. So we'll just move forward. We'll just move forward, right? And try to understand a system of, see, this is the maximum that you have to learn in for with respect to JEE mains, right? And even JEE advanced also, right? So system is like this. You can also, if you want, you can draw. So this is the system we have. This is, let's say, M1. This is, let's say, M2. So in the previous system, we have one pulley, two blocks. Here I have two pulleys, two pulley system. This is a two pulley system. Right? How to go about it? So again, you see, we have a one string here, right? Right? We have one string here. So the tension in the entire string would be same, right? Tension in the entire string would be same because this is one string. There is no knot here and nothing, right? Ideal string. Ideal string, ideal pulleys, right? Pulleys are also ideal. Okay. Okay. Now let me tell you one thing. Let's say this M1 is coming down. This M1 is coming down. Do you think this M2 can also come down? Can you think can both of the blocks come down at the same time? Is it possible?
No, sir.
It is not possible. Why? Because let's say you have to just imagine it, right? Let's say we take both of the blocks to come down. So this has also come down. So this has come somewhat here. So this has also come down. So this has also come somewhat here, right? So you see, if both of them has come down, then there has been some increase in the length of the string, right? Because this amount
Yes,
of
sir.
string has increased, this and this amount, because this has been connected to the pulley, right? So this amount of string and this amount of string has increased. You're getting this? So string's length cannot change, right? You have to
Yes,
understand
sir.
this. So both of the blocks cannot come down together, and both of the blocks cannot go up also, right? Right. Okay. So that means the point is, so that means if this is coming down, this will go, this has to go up, right? Now, can you tell me the constraint relation here?
Sir, I have a doubt.
The constraint relation here. Yes, yes, they will.
Sir, are we saying the whole pulley and M2 moves up, sir? I don't understand the system.
Yes, yes, yes. Obviously, they can move up. No,
So
this can
how is the
happen. No,
whole pulley moving up? I don't get it.
pulley is not fixed. Pulley can move up, right? For
So
this
it's
block to
moving
move
up
up, pulley.
how? From where?
You see, can it not
Okay, wait,
happen?
I got it. I got it. I
No,
got
no,
it.
no. Can it not happen that this has moved like here? Let's
Yes,
say,
because the string length remains the same, it will go up.
acha, you see one thing. If this has moved like this, right? So this pulley has to move up, no? So this pulley moves up like this. So
Yes,
the
sir.
block is attached to this like this, right? So now the length of the string is like this. But it can happen or not.
Yes, sir. Got
You
it.
have to imagine it. Yes, yes, I am explaining it, right? I'll explain. Lipun has said, okay, I'll explain it. Let me see. See, this is a fixed pulley, and this is a movable pulley. Pulley can also move, right? This case can be like this, no? That you see, this has gone down, right? So there has been increase in the length. So here should be decrease, right? And
Yes,
and
sir.
and here and here, pulley is like this, right? It can happen. It can go down further. It will move up further, right? Okay. Now you tell me. Now you tell me. Just this you will get it if you'll imagine it. You'll get it over a period of time. Just tell me what is the relationship between this acceleration and this acceleration. If the acceleration of m1, if the acceleration of m1 is a1 and the acceleration of m2 is a2, right? What do you think is the relation between a1 and a2? Are they same? But in the previous case, we had that the length to be same.
Yes, sir. Here also it's same, so it should be same.
To be same.
No, sir, it won't.
It would not be same. Right now, how to find that constraint relation that I am asking.
Sir, why are we saying it won't be same?
It may be same. We have to calculate first, right? We cannot say like that, right? Because it's a different system, right? So it may be same, it may not be same. In the previous case, it was same, right?
Yes.
Obviously, we cannot determine that just by seeing the diagram. You have to calculate that, right? So how to get that? So that is the constraint relation that you have to just understand the method. So I'm just telling you that, right? So what is the constraint relation? Constraint relation is length of the string should be constant, right? That means L should be constant. Let's say the ideal string should is L, right? So length of the string should be constant. Getting it? And now you tell me one thing. How can I find the length of the string? Let's say I am determining the length. I'm just marking some things, right? So I'm saying that let's say this length is x1. Can I say this? This length is x1. And as m1 will go down, x1 will change. You tell me this.
Yes,
Why
sir. Exactly.
this
Yes.
this this will change or not? As this will go down, this length will change. And can I say that dx1 by dt is equal to v1 is the velocity of the block? And can I say if I'll again differentiate it, that means dv1 by dt or d2 x1 by dt2 is a1. Tell me, can I say this? Do you understand this part? I'm saying that if I'm saying that this is x1, then the change in x1 with respect to time is the velocity. Rate of change of x1 is the velocity of m1, right? Obviously, x1 will increase if it will go down, right? And rate of change of velocity of m1. That means the double differentiation of x1 with respect to time is acceleration a1. Tell me, is it correct?
Yes, sir.
Yes, sir.
Okay. One more thing is there. And let's consider one length from here. From here. Let's consider this length as x2. Can I say this as x2? This is x2. So this is also x2. Right? And as m2 will go up, right? Achha, can I say if the acceleration of a2, if the acceleration of m2 is a2, same is the acceleration of this pulley, right?
Yes, sir.
And as m2 will go up, this pulley will go up, this x2 will change. This x2 will change or not?
Yes, sir.
And it will decrease, right? I'm taking this to be going up. It will decrease. Getting it? Can I say that dx2 by dt by dt is equal to v2 and d2 x2 by dt2 is equal to a2. Why this thing you tell me if you have understood this.
Yes, sir.
Acha, one more thing you just tell me. Yes, Sukruti, it will be dt2, right? That's what I think I've written. No, d2 x2 by dt2. That's what I've written. X2 is this length, right? Actually, tell me one more thing. With time, x2 will decrease or increase?
Please.
Decrease in this case. I'm taking this to be up, right? So this will decrease. So this thing, this rate of change would be negative or positive? It would be negative or positive? It would be negative, right?
Negative.
Because with time, x2 is decreasing. So change in x2 is negative. So v2 should be negative. Obviously, v2 has to come up. No,
Yes.
negative sign is showing the direction, right? Okay, okay, okay. Just this thing, if you're getting, I've just told you this thing that this length is x1, right? So its rate of change will give you velocity and then velocity of m1, and then that's rate of change will give you acceleration of m1, right? And this length is x2, so its rate of change will give you the acceleration of or the velocity of, right? Its rate of change will give you the velocity of m2, right? And that's rate of change will give you the velocity acceleration of m2, right? So this length is somehow connected with the acceleration of m2. This length is connected to the acceleration of m1, right? That's the main point. Now I'm writing the length of the string. What is the length of the string? Can I say length of the string is x1, this x1? Okay. Now I have some length of the string on this pulley also here. Is it there or not?
Yes. Yes, sir.
So let's say the pulley is obviously a disc, a kind of disc. So let's say the length of this pulley, sorry, the radius of this pulley is R1, right? The radius of the pulley But this diagram, you just understand this. Let's say the radius of the pulley is R1, right? From here, I'm taking the length. So what is the length of the string on this pulley? What should be the
Pi
length here?
R1.
Correct, right? This length would be pi r1 or not? The complete is 2 pi r. So this length is pi r1, and this would be constant in any case. This part of the string would always be on this pulley, right? So I'll say
Yes, sir.
x1 plus pi r1 plus, right? What is this length? X2 plus, okay, now we have another pulley. So I have some length here also, right? Its radius might be different. Let's say R2, right? So if its radius is R2, so we have some part of the string here also. Here, getting this. So what is the length here? Pi r2.
Yeah.
Pi R2.
So we'll write x1 plus pi r1 plus x2 plus pi r2 plus again x2, right? Again x2 plus. Now this length is also there, right? What do you think? This part, this part of the length of the string would be constant or not? Can I say it is always constant? It will always be there, right?
Sir,
Let's
but if
call it.
one pulley crosses the other, it will change, right?
How can it be possible? Then to motion will be finished. If this pulley strikes it,
Okay, sir. Yeah.
right, then the string will become loose. Can we say if this pulley surpasses this pulley,
Yes, sir.
or it comes to this its position, that would be the final.
Sir, why won't it go any further? M1 is still going down, right?
How can it go further? Pulley has come here, M2, right?
Yes,
Now this is the string, right? I can have, you see, the string just directly passing here. This is the another
yes,
one,
sir.
right? Near to it. So we have just like this situation we will be having. And just this. What else can be done? Do you think it can go further up?
Sir, if M1 is still going down, then why won't the M2 go up? Why would
Where
it stop there? I don't understand.
this will stop? No. Where is the space? Where is the space here? This is the end of it.
Sir, yeah. Sir, but it can go higher. The first pulley can go higher. There is space above it.
This pulley.
Yes.
Just try to
It,
imagine it.
it can go higher, right?
Let's imagine it that it's go higher, right? So, but I don't think that it is possible. Right now, where will this will not go like this because this pulley is down now, right? I'm imagining that situation. No, that it has gone up.
That it's past it, okay, sir.
So then how this string will like connect? This string will be here, right? How will it go?
Yeah.
That's what I'm saying, that it's not possible. Like how will it go now?
Okay.
Right? How will it
So
be
then it
like?
will stop when they become level. Okay, sir.
Right. Okay. Okay, the point is that we have this portion always constant, right? Always be there, right? So we can neglect it, or we can just take it as, let's say, some C dash, correct? So we have x1, this as C dash is equal to constant. Now you see, what is this equation becomes? X1 plus pi R1 plus 2x2. We have x2 plus x2. Now if I differentiate this equation, differentiating the above equation with respect to time, right? What would I get? dx1 by dt. What is the differentiation of this? Zero, right? It is a constant. Plus 2 dx2 by dt plus, what is the differentiation of this? Again, zero.
Also 0.
What is the differentiation of this? Zero. What is the differentiation of this? Constant, zero.
0.
So you see, we'll be having dx1 by dt is equal to minus 2 dx2 by dt, right? And from here you can say v1 is equal to minus 2 v2. What is the minus sign signifying? Opposite directions, right?
Opposite. Yes.
If one is going downward, the other must go upward. Right?
So you can show the equation. So what is the last term in the equation you have wrote?
Last term C dash.
Yes, sir.
C dash is this length. This last remaining length. This.
Okay,
From
sir.
here, we are just getting x2. This is C dash, and this will always remain here, there, right? So this will be a constant. This will not contribute to any change. Right? And if I differentiate it further, again, what should it be, guys? A1 is equal to
One is
minus 2 of double. ठीक है?
yes, sir.
A1 was the acceleration of M1. Okay, that means M1's acceleration is double of the acceleration of M2, right? So if I'll draw it will collide. What is NRT? Where is NRT? This is not NRT. This is with respect to. This is with respect to. With respect to. That is written as W dot R dot T. Okay. Okay. Right. So now you see this thing. Again, I am drawing the diagram. तो मुझे बताओ अगर ये एक्सेलरेशन if the acceleration of m2 is a upwards, what is the acceleration of m1 downwards? कितना होगा?
A by 2.
That's 2a. A1 is equal to twice of a2, right?
Oh, yes, sir.
तो अगर m2 का एक्सेलरेशन a अपवर्ड है तो इसका एक्सेलरेशन कितना होगा? 2a डाउनवर्ड. ठीक है. इसको आप ऐसा भी देख सकते, you can like see it in that way also. Let's say m2 is going up. Let's say m2 is going up with some distance x, right? So this pulley is going up x, right? This pulley is going up x. Same thing. If m2 is going x up, pulley is also going x. Okay. So if pulley has gone up x, so what is the decrease in the length of this string? Right? Tell me, how much is the decrease in the length of this string? Tell me, if this pulley has gone x up, so this length of the string would decrease or not?
Yes,
By
sir.
this, how much decrease?
By x by 2.
This would also be gone x up, right? So this x has gone, this x has also gone. So what is the decrease? Decrease is 2x. By pulley has gone up. So now pulley has come here, no? So now string would be like this. So this length of the string x and x has decreased or not?
Yes, sir.
By this method, you see, one method is that which I have told you. You just write down the x1, x2, do the differentiation. And one method is this also. You can just analyze it by seeing the system. That you just make this m2 move x up. So if m2 is moving x, that means pulley is moving x up. Because pulley is attached with these two parts of the strings. So this string will also go x, this string will also be decreased by x, right? If length of the string has to remain constant, then decrease in the length of the string should be equal to increase in the length of the string. For the length of string, just take your time to like understand it. Just try to understand whatever you can, right? And do revise it. for the length of string to remain constant, and that is a constraint we have, decrease in the length of string should be equal to increase in the length of string, right? So the decrease in the length of string is happening due to the movement of M2 because M2 is going up, right? So as M2 is going up, so that will lead to the decrease in the length of the string, right? So if M2 is moving x distance, then the decrease in the length is 2x. Then that decrease has to be compensated by the increase in the length by the movement of M1. So you tell me, if M2 is going x up, M2 has to move how much down?
2x down.
2x down. Correct? Because M2's movement by a distance x is decreasing the length. The system is such that is decreasing the length by 2x. So M1 has to move 2x down. So that's why if the acceleration of M2 is a, the acceleration of M1 is 2a. That's the double of that. Got it? If you have any doubt here, just let me know. Just see this thing. Right. We don't have to go into much more complexity than this. But this we have to understand.
Sir, can you explain the pulley part of 2x again?
Yes.
Like pulley moving up.
You see, no. Let's say this is connected, right? This is the connection we are having. I am telling you, this is M2. If this M2 is moving X up, right? So that means that this pulley is also moving X up. This is clear. If let's say the pulley, you see, whenever you are studying one part of the system, just imagine the other part is at rest. Just imagine other things to be at rest, right? So I'm imagining that M2 is going X up, so pulley is also going X up. So let's say pulley has reached here. Right, so pulley has reached here. So now if pulley has reached here, now what is the string? String is only here, from here to here. String is just from here to here now. Right? So this part of the string, you see which part of the string has been lost, has been decreased? This and this. Has it not decreased? Because now the string available here
Yes,
on
sir.
this system is only this. Right? So I'm saying that this decrease, this decrease is 2x. X here, X here. And this
Okay,
has
sir.
to be compensated by its motion 2x down. Right?
Yes, sir. I get it now.
Okay. Okay, guys. Now we have understood this, the constraint that if this is A up, this is 2A down, right? Now we have to solve for the acceleration value, for the tension value. We have to write the equations. How can we write it? For that, we have to draw the FBDs, free body diagrams of M1 and M2. We have to identify the forces on the blocks. So I'm again drawing the system. See, you also just have to practice in drawing the systems. That will not, you should not feel lethargy about it, right? Okay, now you see this thing. That tension is same in the string, right? T. So what are the forces on M1? What can you see the forces on
Weight.
M1? One is the weight, M1G. And what is the force of tension? Tension will pull it upward. Correct. And this M1 is going down with acceleration 2A. This is going up with acceleration A. Right. So how can I draw the FBD? You have to like uh, FBD of M1. FBD means free body diagram. Free body means we have to free the body from the system and identify all the forces. So this is my M1. So one force is this M1G, other force is this T. Correct? And this
Yes,
is
sir.
going down with acceleration 2A. So if this is going down with acceleration 2A, so it must have net force downward. Now from where that net force is coming? That net force is coming due to the difference between M1G and T. Right? So M1G must be greater. So M1G minus T is equal to M1 into what will you write? 2A. M1 into 2A. Okay. Now you tell me about M2. Yes, what about M2, guys? Okay, the caller. So M2, you see, we have one force as M2 into G. What is the other force? See, this is connected here. Is this the same string or same thing or other or different? This.
Different.
This is different. This is not part of the string, right?
Yes, sir.
So let's say this is having some different tension. Let's say T dash, right? So it will pull this M2 with upward force T dash, right? So this M2 FBD of M2, if I'll draw FBD of M2, so it will be having downward force M2G and upward force as T dash. and it is going up with acceleration A. Right. So what is the equation I can write? T dash minus M2G is equal to M2A. Right. But now the point is, what is T dash? How can we find T dash? Right. Now we look at this pulley. Just observe this pulley now. This one. P2. This is my P2 pulley 2. Let's say this is my P1 pulley 1. So I'm talking about this P2. Just try to understand this. Right. P2. Okay. We have ideal pulley. Right. Ideal pulley has one characteristic, that it is massless. Ideal pulley is what? Massless. Right. Very negligible mass it has. Right. So what is the mass of this pulley? Mass of this pulley is approximately 0. Right. Negligible mass. Okay. Now you tell me one thing. Now this pulley is also attached with this. Attached or not? So if this is T dash, it is pulling this block with T dash. This part, this thing, this rod or string is also pulling this P2 with T dash or not?
Yeah.
Well, you see, this is also connected with P2, right? And now you see, these strings are also attached with pulley here and here. This is constant, right? This is not. So these strings are also pulling this pulley, right? So this string is having tension T. So this string is pulling this pulley with tension T here and also with tension T here. So on P2, we are having one force of tension here also and one force of tension here also, due to the connection with the string.
Yes.
Right. Now, is this pulley also going up? If this M2 is going up with acceleration A, what is the acceleration of the pulley? Also A.
Yes, sir.
Acceleration of the pulley is also A. Right. So how would we write that? So we have two forces here, 2T above, T dash down. So how will we write the equation? Can I say for pulley P2, can I say that 2T minus T dash is equal to mass of the pulley into acceleration of the pulley? Tell me,
Yes,
can I
sir.
say this? Now, what is the mass of the pulley? It is 0. So that means, can I say 2T minus T dash is equal to 0? That means T dash is equal to 2T. Getting it? So whenever we have an ideal pulley, right? This thing we can write down straightforward only. We can be sure about it that if this is T, this is T, so this tension has to be 2T. Tell me, right? So now you can put here, so the equation, this is not 2, our second equation would be T dash will put 2. So 2T minus M2G is equal to M2A. This is my second equation. So now I can solve that, right? First and second. How can I solve it? Here I have 2T, here I have minus T. So can I multiply this equation with 2?
Yes.
If I'll multiply this whole equation with 2, but I hope you are understanding this. You see, I am just showing you by zooming in. I think you can understand this, right? So you see how, what is the first equation now becomes 2m1g minus 2t is equal to 2 to the 4, 4m1a. And then I'm adding it with 2t minus m2g is equal to m2a. Right? I'll just add it. If I'll add it, this 2 minus 2t, 2t will get cancelled out. It would be 2m1g minus m2g is equal to 4m1a plus m2a. Right? So you can see what is my acceleration here. I can take this gs common. And here I can have 4m1 plus m2a. So acceleration comes out to be 2m1 minus m2 into g upon 4m1 plus m. Tell me correct. You have to understand all the points that we have discussed here, right? And now as we have got acceleration, we can find the tension's value, right, from any equation. Can you find it? Please look at this and let me know if anything has to be told again, or if you have any other doubt. Hmm. Is it tension you are getting?
Yes, sir.
So, but tension does not have any role of M1 and M2. It is not coming.
So I think there is some error in the calculation because M1 and M2 are getting cancelled for me.
I don't think so that that will be the case. If I have an interesting question here, just to try it out, right? We'll discuss that in the next session.
So now I got it.
That is M1, M2, right?
Yes, sir, there is.
Hmm. So this is the question. You just have to tell the relation. Just try it out. And also you see connected to this. See, you have to solve these questions, right? The same type of situation is this, right? So both of them are JEE Mains questions. So this one you'll be able to do quite right. And this one also you please try. I'm also putting these questions on the WhatsApp. All right, guys. So just go through them. Go through all the pulley block concepts that we have done, right? Next session, we'll be doing something like I'm thinking of starting with friction, right? So we'll be starting with friction, right? We'll be taking friction topic in the next session, right? So whatever we have done in the laws of motion, just try to like consolidate that and do its revision, right? All right, then let's connect in the next session. And if you have any doubt, please let me know. Okay, guys, thank you.